যাই হোক, কেমিস্ট্রি ক্লাসে তোমাদেরকে স্বাগত। নাও ওয়েলকাম টু দ্য কেমিস্ট্রি ক্লাস. Now today I am discussing about chemical kinetics. So what is chemical kinetics? To understand this, we have to first understand the reaction, chemical reactions. I think we know something about chemical reactions. Chemical reactions, there are some types of chemical reactions. Which type of chemical reactions? Some chemical reactions are the rate of that type of reaction is very high. There are some chemical reactions whose rate is very slow. Okay. These two type of chemical reaction, we cannot determine the rate of these two type of chemical reaction, because the very fast reaction, the rate is very fast, so we cannot determine it. The very slow reaction, it will be time lag process, so it cannot determine it. So our interest in this chapter is to determine the rate of the reaction whose rate is medium, means not so high, not so slow, or not so low. Okay. So first we have to know the rate of reaction. What is the rate of reaction? Rate of reaction is definition of rate of reaction is the change of amount of species in a chemical reaction with time is called rate. The definition, we can tell that the change of amount of species means reactant or product. Change of amount of reactant or product with time in a chemical reaction is called rate. In other words, we can tell that the extent of reaction or advancement of reaction with time is called rate. Okay, definition হয়ে গেল। এবার হচ্ছে unit of rate. What is rate? Rate is equal to change of concentration, so concentration divided by time. So what is the unit of concentration? Unit of concentration is mole liter inverse by second. So unit of rate will be mole liter inverse second inverse. Okay. Now consider a reaction, chemical reaction. A plus B to B. C D. We can consider this chemical reaction. Sorry, 4. Okay. So these are the reactant of the reaction, these are the product of the reactions. Now dA by dt, what is this? This is the change of concentration of A with time. We can tell this as the rate of change of concentration of A. Here it is negative, so rate of disappearance of A. This is rate of disappearance of A. What is this? This is also rate of disappearance of B. So okay, now 1 mole of A, এটা আপনি একটু ভাবি যে 1 mole of A disappear means as these are the reactants, so with increasing the time or with advancement of the reaction or with the progress of the reaction, the concentration of this reactant decreases. So So we think that concentration of A means 1 mole of A ডিসঅ্যাপিয়ার করতে যে টাইম লাগছে সেই টাইমে 2 মোল অফ এ ডিসঅ্যাপিয়ার করছে। এটা দেখা যাচ্ছে তো এখানে 1 মোল এ ডিসঅ্যাপিয়ার করতে যে টাইম নিচ্ছে সেই টাইমে 2 মোল অফ বি ডিসঅ্যাপিয়ার করছে। সো হুজ রেট অফ ডিসঅ্যাপিয়ারেন্স ইজ হায়ার between A and B? Obviously B. No. Obviously B. So the rate of disappearance of B is higher. Higher means twice. Here rate of disappearance of B is twice than the rate of disappearance of A. So we can write here like this way. 2 into is there any problem? Rate of disappearance of A is equal to half into rate of disappearance of B. Here the negative sign indicates the rate of disappearance. We have to write here the negative sign. So this is equal. Now rate of reaction. Rate of reaction is this change of concentration of reactant with time. This. So rate of the reaction is this. As there is no coefficient like 2, 3, 4. There is no coefficient like 2, 3, 4. So the rate of reaction is equal to negative d concentration of A by dt is equal to minus 1 by 2 d concentration of B by dt. This 2 is coming from this coefficient. Okay. Same we can write d concentration of C by dt. What is this? Rate of accumulation of C. Why this is accumulation? Means these are the products. So the concentration of product increases with increasing the time or with progress of the reactions. So this is rate of accumulation of C. Okay. Same theory like this way we can write here rate is equal to 1 by 3 d concentration of C by dt is equal to 1 by 4 d concentration of D by dt. So we can write a reaction. Now let us consider a chemical reaction like this that way. Now let us consider a chemical reaction like that way C D. So rate is equal to 1 by A d concentration of A by dt equal to 1 by negative sign obviously because this is the reactants and reactant A whose concentration decreases with advancement of the reaction or with progress of the reaction. Obviously for this B d concentration of B by dt equal to plus 1 by C d concentration of C by dt plus 1 by D d concentration of D by dt. Why this is plus? This is plus because these are the products. So the concentration of the product increases with increasing the time or progress of the reaction. Okay. So this is a formula. So now what is this? D concentration of A by dt. What is this? D concentration of B by dt. This is the rate of disappearance of A this is rate of disappearance of B, this is rate of disappearance of rate of accumulation of C, and this is rate of accumulation of D. Now when it is multiplied with 1 by A, it becomes the rate of the reaction. Now when it is multiplied by 1 by its coefficient, it is equal to, it will be equal to the rate of the reaction. The same theory is for C and D. Okay. Now consider a graph for a chemical reaction. Here it is T, time, the concentration in the y-axis, and the x-axis time. So we obtain this type of two graphs here. One is this and another is this. This is for reactant. This graph is for reactant molecule, reactants. Why this is reactants? Think that at T is equal to 0, here the T is equal to 0, the concentration of the reactant is high. With increasing the time, the concentration of the reactant decreases gradually, and this. So this graph is for reactant, and this graph is for products. Why this is products? At T is equal to 0, the concentration of products are 0. With increasing the time, the concentration increases gradually, and so this is for products. Okay, reactants and products হয়েছে গ্রাফটা হলো. Now we have to know about the rate law. What is rate law? Definition of rate law. Actually, in chemical equilibrium in class 11 we have found that for a arbitrary reaction like that way B product, that way rate of the forward reaction is directly proportional to the concentration of A to the power A, concentration of B to the power B. We have found that in class 11 in chemical equilibrium chapter. So this, if we withdraw this equilibrium proportional sign, so we obtain here a concentration term. This concentration term is called rate constant of reaction. This is rate law. This equation is called rate law. So what is the definition of rate law? Rate law is the expression in which the rate of a reaction is related with the concentration of the species or reactants or products involved in the reaction. Okay, so rate law is the expression in which rate of a reaction is related with the concentration of species of the reaction. Okay. Now rate constant. Next topic, rate constant. What is rate constant? From this reaction we can obtain, from this equation we can obtain rate constant. K is equal to rate divided by concentration of A to the power A, concentration of B to the power B. So here we can obtain that rate constant. Definition of the rate constant. Rate constant is defined. Rate constant is the ratio of rate of a reaction and the amount or concentration of the species involved in the experimental rate law. Rate constant Karkar ratio. Rate constant is the ratio of amount of reaction. Rate constant is the ratio of rate of reaction and the concentration of species involved in the rate law. Rate constant হচ্ছে রেট এবং এই যে কনসেন্ট্রেশন অফ দ্য স্পিসিস যেটা কিনা এই রেট লতে আছে তাদের রেশিও। ওকে, একটা ডেফিনেশন গেল। অন্যভাবে মানে ইন অ্যানাদার ওয়ে দ্য উই ক্যান ডিফাইন রেট কনস্ট্যান্ট লাইক দ্যাট ওয়ে দ্যাট ইফ নাও ইফ concentration of A and 1 concentration of B is unit, so rate constant K is equal to rate. So now we can define rate constant like that way, the rate of the reaction of at unit concentration is called rate constant at unit concentration of the species. Rate constant in another way, rate constant can be defined as the rate of the reaction at unit concentration of the species involved in the reaction is called rate constant. Okay, ঠিক করে লিখতে আচ্ছা Now rate constant, so the rate constant can also be termed as a specific rate. Specific rate. Why specific rate? Specific rate because rate constant is the rate of the reaction at unit concentration of the species. So this is called as specific rate. The next question is difference between rate and rate constant. Okay, difference between rate and rate constant. So write down in tabular form. The first point is unit of rate. Write down in tabular form, means in that way, rate constant K. First point is unit. What is unit of rate? I have told unit of rate is mole liter inverse second inverse, concentration by second. And unit of rate constant is not fixed. It depends upon the type of the reaction. Unit of rate constant depends upon the type of reaction. Which type of reaction is this? Means we have seen that for the first order reaction, for the second order reaction, this type of reaction, for the first order reaction the rate constant is different, for the second order reaction the unit of rate constant is different. Okay, the next point is rate depends, means decreases with time. Not only depends, rate decreases with time, but rate constant is a constant term, so it does not change with time. Third point is rate depends upon the concentration of the reactant or the species. Rate depends upon the concentration of the reactant. Rate constant is a constant term. It is independent on the concentration of the reactant. Okay, so the difference is completed. The next topic is order of the reaction. Order of the reaction. Definition. What is the definition? Definition is the order of the reaction. Order হচ্ছে the sum of the power of the concentration term. The sum of the power of the concentration term involved in the chemical reaction. involved in the experimental rate law. Rate law is called order of the reaction. The sum of the power of the concentration term involved in the experimental rate law is called order of the reaction. Okay, এটাকে একটুখানি বুঝতে হবে what is order of the reaction. So let us take an example. A plus B product. Let's the rate law is equal to rate law টা কি হবে? Rate is equal to rate constant K into concentration of A to the power A, concentration of B to the power B. Now this is the rate law, experimental rate law. Why this is experimental? This is experimental because this cannot be determined theoretically. This equation is calculated and this equation is totally experimental fact, depends upon totally experimental fact. এক্সপেরিমেন্ট করে এই ইকুয়েশনটা পাওয়া গেছে, এটা কিন্তু থিওরিটিক্যালি আমি লিখতে পারবো না। ইকুয়েশন দেখে আমি যতটা ইজি করে ইকুয়েশন দেখে এটা লিখছি, এটা কিন্তু ততটা ইজি না ইকুয়েশন দেখে লেখাটা। পরে পড়বো যে অনেক কমপ্লেক্স অনেক রিয়াকশন আছে যেগুলোকে আমরা লিখতে পারবো না এটা দেখে। So rate law is an experimental fact. We cannot write rate law by just watching the reaction, chemical reaction. Okay, we have to do some experiment. After experiment we can write the rate law, this rate law. So rate law is an experimental fact, not theoretical fact. Okay, rate law. So the order is that A plus B. A plus B. The sum of the power of the concentration term A and B are the two concentration term. Their powers are small a and small b. Their sum is called order of the reaction. Now the factors affecting order of the reaction. কোন factor on which factor the order of the reaction depends? Does the order of the reaction depend? Or the some points about order of the reaction. Points I have written a some points about order of the reaction. Which are the points? Points means, that is first point, order of the reaction must be an integer, not true. This means order of the reaction may not be integer, must not be integer. Okay, order of the reaction may be integer, fraction, negative, even zero. Order of the reaction may be integer, fraction, negative and zero. Order of the reaction is totally experimental fact. Not theoretical fact. Okay. So, and the order of the reaction, there is no connection between the order of the reaction and stoichiometricity of the reaction. So what is the stoichiometricity? Stoichiometricity is this: A and B are the stoichiometricity of the reaction. So there is no connection between the order of the reaction and the stoichiometricity of reaction. Sometime before I told you that the order of the reaction is a experimental fact. Here it is seen that we write easily আমি খুব ইজিলি লিখলাম যে এই ইকুয়েশন থেকে কনসেন্ট্রেশন অফ A to the power A, but this is not so easy like that way. So the order of the reaction, we have to keep in mind that order of the reaction is an experimental fact, and there is no connection between the order of the reaction and stoichiometricity of the reaction. Okay. So, and the higher order of reaction is rare. Higher order reaction is rare. Order reaction is rare. Now, the next topic is molecularity of the reaction. Molecularity of the reaction. So, what is molecularity? Molecularity is, definition of molecularity: the number of molecules involved in a chemical reaction is called molecularity of that reaction. The number of molecules involved in a chemical reaction is called molecularity of the reaction. Okay. So molecularity we can write here as a chemical reaction. Let A plus B plus C product. So molecularity must be A plus B plus C. This is molecularity. আমাদের মনে হতে পারে যে আমি অর্ডার অফ দ্য রিয়াকশনও তো এরকম হতে পারতো, কিন্তু বারবার বলছি অর্ডার অফ দ্য রিয়াকশান আমি যেমন করে সোজাভাবে লিখেছি আগে সেই রকম অর্ডার অফ দ্য রিয়াকশন হয় না, ঠিক আছে? আমি সাধারণত একটা বোঝাবার জন্য আমি ওরকমভাবে লিখেছি। ওকে, now what is the difference between order and molecularity? Now next question is difference between order and molecularity. Difference between order and molecularity. This is order, molecularity. Order of the reaction, first point is definition. You can write here the definition. The second point is order of the reaction may be integer, fraction, maybe integer, maybe fraction, maybe zero, maybe negative, but the molecular of reaction must be integer. No fraction, no negative, no zero. Molecularity of the reaction must be integer. Okay. Next point is order of the reaction is an experimental quantity. The molecularity of a reaction is a theoretical quantity. The next point is, fourth point is, higher order of reaction is impossible, but higher molecularity of a reaction is possible. Okay, these are the 4 points of differences between molecularity and order of the reaction. Now some concept about what is molecularity, some relationship between molecularity and order of the reaction. Let us consider a chemical reaction. একটা chemical reaction কথা আমি ভাবছি, which is multi-steped. একটা মাল্টি-স্টেপ রিয়াকশানের করতে আমি করছি, যেটা একটা রিয়াকশান যেটা একটা স্টেপ, 2টো স্টেপ, 3টে স্টেপ, 4টে স্টেপ, এরকম অনেক কটা স্টেপে হচ্ছে। তো ইন কেস অফ মাল্টি-স্টেপ রিয়াকশান, the order of the reaction is the total molecule involved in this fourth step, the sum of the total molecule involved in the fourth step. এই চারটে স্টেপে যে টোটাল মলিকুল ইনভলভ হচ্ছে সেটা হচ্ছে অর্ডার অফ দ্য রিয়াকশন, molecularity of the reaction. ব্যাপারটা কি, the total number of molecules involved in these four steps, this is molecularity of the reaction. But এই কটা চারটে স্টেপের মধ্যে একটা স্টেপ হচ্ছে, যে কোনো একটা স্টেপকে আমাকে বাঁচতে হয় যে বা চুজ করতে হয়, which is slower step. Let us the third step is slower step. This is called rate determining step, RDS, rate determining step. Means শুরুতে at the first beginning I told you that we cannot determine the rate of a very fast reaction, and we cannot determine the rate of very slow reaction. We can determine the rate of the reaction whose rate is medium, which is not very fast and which is not very slow. So among these four steps, the step whose rate is medium, this is called RDS, rate determining step. We have to determine the rate of this reaction. Now the order of the reaction is the molecularity of this step. Means the number of molecules involved in this slow step is called order of the reaction of the total reaction, order of the total reaction. But the molecularity is the sum of these four steps. Molecularity is the sum of the molecules, number of molecules in this fourth step. Okay, so I think you can understand the difference between order and molecularity. Order is the molecularity of the slower step of a chemical complex reaction. Order is the molecularity of the RDS, rate determining step or slow step of a complex reaction. Complex reaction means each contains so many steps, but the molecularity is the total number of molecule involved in the whole reactions, means total steps 1 2 3 4, এই টোটাল স্টেপ মিলিয়ে যতগুলো মলিকুল ইনভলভ হচ্ছে সেটা হচ্ছে molecularity of the reaction. Okay, so now when the order and molecularity of a reaction become equal,